Hi friends, today we are discussing the relationship between the zeros and the coefficients of a polynomial. In our last video, we have seen that the zero of a linear polynomial ax plus b is minus b by a. Now let us see the relationship between the zeros and the coefficient of a quadratic polynomial. Let us consider a quadratic polynomial. P of x is equal to 2x square minus 8x plus 6. We have learned to factorize this polynomial by using splitting the middle term. So here the middle term is minus 8x. We are going to split this middle term to factorize this. So for splitting the middle term minus 8x, we have to find out two numbers such that their sum is minus 8x and their product is 2x square into 6, that is 12x square. So such two numbers we have to find out. So sum is minus 8x. So let us consider two numbers minus 2x and minus 6x. Let's see their sum. Minus 2x plus minus 6x is minus 8x and their product is 12x square. So we rewrite this polynomial p of x as 2x square minus 6x minus 2x plus 6. Now we consider the first two terms. So 2x square minus 6x we write in one bracket, then minus 2x minus 6. Now in the first bracket 2x is a common factor. So let us take 2x outside. So this become now x, then here remaining 3. Now minus, here 2 is common factor. So x minus 3. Now two terms are there, 2x into x minus 3 minus 2 into x minus 3. So here x minus 3 is a common term there. So this is equal to x minus 3. Now in the first term 2x remaining there. So 2x minus 2. Now this is equal to x minus 3 into then 2x minus 2. Again 2 is common there. So that 2 we are taking outside, then remaining here x, here remaining 1 into 2. So p of x is equal to 2 into x minus 3 into x minus 1. So the value of p of x is equal to 2x square minus 8x plus 6 is 0 when x minus 3, either x minus 3 is equal to 0, that is p of x, the value of p of x is 0 when either x minus 3 is equal to 0 or x minus 1 is equal to 0. Here 2 is never 0. Okay. So x minus 3 is equal to 0 or x minus 1 is equal to 0. Now x minus 3 is equal to 0 implies x is equal to 3. Now x minus 1 is equal to 0 implies x is equal to 1. So 1 and 3 are the zeros of this quadratic polynomial. P of x is equal to 2x square minus 8x plus 6. Okay, now the zeros of P of x is 1 and 3. Now let us find their sum, that is sum of these two zeros, 1 plus 3. What is 1 plus 3? Which is equal to 4. This 4 can be written as 8 by 2, or it can be written as minus of minus 8 by 2. Now what is minus 8 here? That is, we just compare this minus 8 with the coefficients of the terms of this quadratic polynomial. So let us see that minus 8 is the coefficient of x there. So this can be written as minus of the coefficient of x divided by, what is 2 there? Let us check. 2 here, this 2 is the coefficient of x square. So coefficient of x square. So what we got now? Sum of the zeros is equal to minus of coefficient of x divided by coefficient of x square. Now let us find their product, 1 into 3. Find the product of the zeros, which is equal to 3. Now this can be written as 6 by 2. Now again let us compare this 6 by the coefficients or the terms of the polynomial. So 6 is here the constant term. So it can be written as the constant term divided by then 2, the coefficient of x square, the coefficient of x square. So from this we get a relation, that is sum of the zeros of a quadratic polynomial is minus of the coefficient of x divided by the coefficient of x square. Then the product of the zeros of a quadratic polynomial is constant term divided by the coefficient of x square. If you check at this as true, let us see that for other examples also this relationship holds true. That is, if we consider some other examples and if you check at this as true for this coefficient, this relationship, let us see that it holds true for those examples also. So let us generalize this. So if alpha and beta are the zeros of a quadratic polynomial, p of x is equal to ax square plus bx plus c, where a not equal to 0, then x minus alpha and x minus beta are two factors of the polynomial p of x is equal to ax square plus bx plus c. Therefore ax square plus bx plus c is equal to that is, if x minus alpha and x minus beta are two factors of ax square plus bx plus c, then this polynomial is equal to k into x minus alpha into x minus beta. So it can be written as k into, just to multiply these two brackets, so x square, then x into minus beta x, then minus alpha x, then minus alpha into minus beta, minus into minus plus alpha beta. Distribute this k to the terms inside the bracket. So we get kx square. Now here x is a common, so k into, take that x common factor from both terms. Then there remains alpha plus beta. Alpha plus beta, that is minus kx alpha, then minus kx beta, plus. Now by comparing the coefficients of x square, x and the constant term on both sides, we get here the coefficient of x square is here a, and that is here k. So by comparing their coefficient, we get a is equal to k. A is equal to k. Now the coefficient of x, here it is b. Now here the coefficient of x is minus k into alpha plus beta. So b is equal to minus k into alpha plus beta. Now the constant term, on the left side it is c, right side it is k alpha beta. So c is equal to k alpha beta. Now from the second relation we get, that is b is equal to minus k into alpha plus beta. Here what is alpha and beta? Alpha and beta are the zeros of this quadratic polynomial. So alpha plus beta is their sum of the zeros. Now so the sum of the zeros, or alpha plus beta, is equal to, we take this minus k to the left side of the equal to sign. So we get b by minus k, that is minus b divided by k. Now from first a is equal to k. So for k we give the value a. So alpha plus beta is minus b by a. Now what is b? The coefficient of x. And what is a? The coefficient of x square. So alpha plus beta is equal to minus of the coefficient of x divided by the coefficient of x square. Now let us see their products. C is equal to k into alpha beta. So what is alpha beta? Or the product alpha beta is their product. So alpha beta is equal to c by k. Again c by, what is k? A. So alpha beta is equal to c by a. What is c? Here the constant term. A, the coefficient of x square. So this is equal to the constant term divided by the coefficient of x square. Coefficient of x square. So this is the relation between the zeros and the coefficient of a quadratic polynomial. That is, the sum of the zeros is equal to minus the coefficient of x divided by the coefficient of x square, and the product of the zeros is equal to constant term divided by the coefficient of x square. Okay, let us do one example. This is the question. Let us just go through the question. Find the zeros of the polynomial x square minus 3 and verify the relationship between the zeros and the coefficients. So we first, in the first part of the question, we have to find out the zeros of this quadratic polynomial x square minus 3. Then the second part, verify their relationship between the coefficient and the zeros. So here the given polynomial p of x is equal to x square minus 3. So let us just recall one identity that is we have learned earlier, a square minus b square. So what is a square minus b square? We have learned this identity in class 8, I think. So a square minus b square is equal to a plus b into a minus b. This identity we make use to find the zeros of this quadratic polynomial. So we just rewrite this x square minus 3 as x square minus 3. 3 can be written as root 3 this square. So x square minus 3 is equal to x minus root 3. Now this is of the form now a square minus b square. Here a is x and b is root 3. Okay, so it can be written as x plus root 3 into x minus root 3. So p of x or x square minus 3 is equal to x plus root 3 and x minus root 3. So the values of x square minus 3 is 0 when x plus root 3 is equal to 0 or x minus root 3 is equal to 0. Okay, that is the value of x square minus 3 is equal to 0 when either x plus root 3 is equal to 0 or x minus root 3 is equal to 0. Now x plus root 3 is equal to 0 implies x is equal to minus root 3. Then x minus root 3 is equal to 0 implies x is equal to root 3. So minus root 3 and root 3 are the two zeros of this quadratic polynomial x square minus 3. Right? So these are the two zeros, minus root 3 and root 3. Now the second part, verify the relationship between the zeros and their coefficients. So let us find the sum of these zeros and let us find their products. So first sum, that is root 3 plus minus root 3. What is root 3 plus minus root 3? That is root 3 minus root 3, which is equal to 0. So their sum of the two roots is 0. Now this 0 can be written as 0 divided by 1. 0 divided by 1. Now what is 0? By comparing the coefficient of this given quadratic polynomial, x square minus 3, it can be written as this x square minus 3 can be written as x square minus or plus 0x minus 3. So 0 is here the coefficient of x. So this is coefficient of x divided by then 1, this is 1 coefficient of x square. So it's true. Second, root 3 into minus of root 3. So root 3 into minus of root 3 is equal to minus 3. What is minus 3 here? Minus 3 is the constant term, or this minus 3 can be written as minus 3 by 1. So now minus 3 is the constant term. So this is equal to constant term divided by 1 is again the coefficient of x square. So their roots holds the relationship between the coefficient and the zeros of a quadratic polynomial. Next we consider a cubic polynomial. Let us check whether it holds a similar relationship between the zeros and the coefficients. Consider the cubic polynomial p of x is equal to 2x cubed minus 5x square minus 14x plus 8. By trial and error method, we get for minus 2, 1 by 2 are the zeros of this cubic polynomial. Then let us find their sum. That is, we are going to find the sum of the zeros. So sum is equal to 4 plus minus 2 plus 1 by 2, which is equal to 4 plus minus 2 is 2, 2 plus 1 by 2 is 2.5, or let us write it as 5 by 2. Now this 5 by 2 can be written as minus of minus 5 by 2. Minus of minus 5 by 2. Do you have any doubt about why do we write this 5 by 2 as minus 5 by 2? That is, we are going to compare this sum with the coefficients of this cubic polynomial. To compare this with the coefficients, we are writing this as like this. Okay, so minus of minus 5 by 2. Now minus 5, here what is minus 5? It is the coefficient of x square. What is 2 here? It is the coefficient of x cube. So let us rewrite it as, or this is equal to minus of coefficient of x square divided by this 2 coefficient of x cube. So the sum of the zeros of a cubic polynomial is minus coefficient of x square divided by the coefficient of x cube. Now let us find their product. So product is equal to, here 4 into minus 2 into 1 by 2, which is equal to minus 8. Minus 8 into 1 by 2 is minus 4. So this minus 4 can be written as minus 8 by 2. We just changing this minus 4. Minus 4 is equal to minus 8 by 2. Again, to compare this with the coefficients. So now here what is minus 8? 8 is the constant term there. Now 2 is again the coefficient of x cube. So this is equal to minus of the constant term divided by coefficient of x cube. So now we are going to find the sum of their pairwise product, that is 4 into minus 2 plus minus 2 into 1 by 2 plus 1 by 2 into 4. Now this is minus 8 plus minus 1 plus 2. Minus 8 plus minus 1 minus 9 plus 2 is equal to minus 7. Again this minus 7 can be written as minus 14 divided by 2. Now let us compare. Minus 14 is here the coefficient of x. 2 is again the coefficient of x cube. So this can be written as coefficient of x divided by coefficient of x cube. That is, sum of the pairwise product of the zeros of a cubic polynomial is coefficient of x divided by coefficient of x cube. So if alpha, beta, gamma are the three zeros of a cubic polynomial, ax cube plus bx square plus cx plus d where a not equal to 0. if alpha, beta and gamma are the three zeros of a cubic polynomial ax square plus cubic polynomial ax cube plus bx square plus cx plus d were a not equal to 0, then we have alpha plus beta plus gamma, that is sum of the roots, is equal to minus b by a, that is minus of the coefficient of x square divided by the coefficient of x cube. Second relation, their product, that is alpha into beta into gamma, that is product of their zeros, which is equal to minus d by a, that is minus of the constant term divided by the coefficient of x cube minus d by a, that is the product of the zeros. Now let us find alpha beta plus beta gamma plus gamma alpha, which is equal to c by a, that is coefficient of x divided by coefficient of x cube. So these are the three relationship of a cubic polynomial. So these are the three relationship between the zeros and the coefficients of a cubic polynomial. Okay, so thank you very much.